for those who are attending, please scan your attendance in e-learning. I believe Dr. Dayang also post have
already post
activated
attendance.
the attendance QR code. So just log on to e-learning and scan your attendance. Okay. So I'm going to start. Before that, let me start the recording, yeah. Can you see what I'm sharing?
Yes, Doctor.
Okay, thank you. The main purpose for tonight's replacement lecture is actually to give you an overview, overall conclusion, I would say, for this topic number 1, conduction, and of course to also answer your questions if you do have. Okay, I believe you should have that. Okay, otherwise you can be our instructor. Okay, let me start here. Okay, all this you have gone through already. Okay, so I just want to give you some additional information. Okay, additional information. This is what you were taught, right, during the from the video lecture, recorded lecture, right? What is conduction? What is convection? What's radiation? But it's rather simple. To me, I think is too simple. So now I want to give you more explanation so that you would be able to have a deeper understanding on conduction and convection especially. Okay, so what is conduction? So this is, I took it from a textbook, okay, not the textbook you use, but another textbook, heat and mass transfer. Okay, so as you can see here, the definition of conduction given by the authors is conduction is the transfer of energy. So from the more energetic particles of a substance to the adjacent, less energetic ones as a result of interactions between the particles. Okay, and conduction can take place in solid, liquids, or gases. Maybe this is something new to some of us. Okay, maybe in the past we, especially in the high school, maybe we were taught conduction is the heat transfer for solid. Convection is heat transfer for fluid, meaning for liquid and gases, right? So just want to tell you something more. So conduction can take place in solids, liquids, or gases in all the 3 phases. Okay, and according to this definition, so you can see what is the key words here. I have highlighted using the red color font. So conduction is transfer of thermal energy from where? From more energetic particles to the adjacent, meaning bersebelahan, if BM lah. Okay, so from more energetic particles to the particles next to the particles. Okay, adjacent and less energetic ones. Okay, as a result of what? Interaction. There must be interactions between particles. So what are the possible interactions? Okay, it depends on types of particles. Okay, if it contains free electrons, then free electrons movement. right? If it doesn't contain free electrons, then it's due to vibrations. Okay, so the interactions here means different things for different types of material. Okay, and if for gases, liquids, it's basically collision, right? Collision between molecules. Okay, or if for some gas, monoatomic gas, for example, argon, right? Then is collision between atoms. Okay, so this is definition of conduction, and I believe it's quite clear and straightforward. But let's see convection. Convection is a little bit complicated. Okay, so let's see the definition of convection. Okay, why this is important? Let me tell you. This subject, if you see the CI, course information, you will see CLO number 1, course learning outcome number 1. You are required to explain, okay, to explain some of the phenomenon. Okay, CLO number 1. So, meaning in our assessment, you will be asked to give explanation. Okay, that's why I give you more information. I give you explanation so that because after this, in the test, in the quizzes, in the final exam, you will be required to explain, to give explanation. And based on our experience, previous cohorts of students, I think explanation is one of the weakest part of the students. Okay, so normally students only focus on calculations, how to use formula. Okay, and we will see this weakness very clearly, very obvious when students do report writing in their final year. Okay, in your final year, you're going to take PSM, final year project 1 and 2, right? You're going to prepare your proposal. You're going to read so many different journal papers. Then from there, you're going to write proposal. Then PSM2, you're going to conduct experiment. Then you're going to write chapter 4 of your PSM, or people call that thesis, is results and discussion. You're going to discuss your result. So if you don't learn how to explain, then you are going to suffer in your PSM 1 and 2. Okay, so that's why we start training you how to do explanation, okay, since your first year, second year. Okay, and since this is part of the course learning outcome, so I hope you pay attention in this, and you will also learn how to explain some phenomena, okay, in transport. Okay, let's come back to convection. So convection, definition of convection is mode of energy transfer, you see, keyword between a solid surface and the adjacent liquid or gas. So convection is what? Convection, it happens between a solid surface and the adjacent liquid or gas. Between a solid surface and a fluid in motion. So meaning between convection is heat transfer between a solid surface and a moving fluid. Okay, to put it in a very simple language. Okay, and let's see, and it involves the combined effects of conduction and fluid motion. Okay, so the faster the fluid motion, the greater the convection heat transfer. So it depends on the fluid velocity. Okay, fluid velocity. So that's why when you enter topic number 2, convection, I believe you learned already. You have taken this subject called fluid mechanics. So you know what is this, right? Can you please tell me what's this? What is this? NRE.
Is it Reynolds number?
Yes, Reynolds number. So you learn in fluid mechanics, right? Reynolds number. So what you have learned in fluid mechanics, you're going to use it in convection. Do you still remember the formula for fluid for Reynolds number? Rho V D or L per mu, right? Okay, so the higher the Reynolds number, that from the Reynolds number you'll be able to tell the flow is turbulent or it is laminar, right? So in the next topic, these are what you are going to learn. Okay, so the faster the fluid motion, the greater the convection heat transfer. Okay, and in the let's see, in the absence of any bulk fluid motion, heat transfer between a solid surface and the adjacent fluid is by pure conduction. Okay, and so what is convection? Convection is actually conduction plus fluid motion. Okay, conduction in the presence of moving fluid. To put in a simple language. Okay, and let's see the remark here. The remark here. The textbook author say some people do not consider convection to be a fundamental mechanism of heat transfer. Why? Because it is essentially, excuse me, it is essentially heat conduction in the presence of fluid motion. Okay, but why? Let's see. Let's continue to see. But we still need to give this combined phenomenon a name, unless we are willing to keep referring it to as conduction with fluid motion. So it is practical to recognize convection as a separate heat transfer mechanism, despite the valid argument to the contrary. Okay, so it means some people don't assume convection as a fundamental heat transfer mechanism. Okay, but since you still need to give it a name, right? Because the name is long. You cannot say heat conduction in the presence of fluid motion, right? So that's why we give it a name. It's called convection. Okay, so next time when you recall what is convection, convection is actually conduction take place in together with fluid motion. Okay, as simple as that. Okay, so let me okay. After this, I'm going to explain to you how convection takes place. I'm going to explain to you mechanism of convection. Okay, now I tell you the definition first. Okay, so you bear in mind first the definition of convection. Now let's see what is radiation. Okay, radiation is the transfer of thermal energy between bodies through what? Through electromagnetic waves. And it happens at the speed of light and doesn't require a medium. Okay, that's why the heat from the sun is able to reach the earth because that happened through radiation. I think all this we know, right? So, and all bodies at a temperature above absolute zero, meaning above 0 Kelvin, emits thermal radiation. Okay, meaning all of us, everything, I would say everything, all the bodies, as long as the temperature of the body is above 0 Kelvin, then it emits thermal radiation. Just that when the temperature is higher, then the amount of thermal radiation emitted by that body is higher. Okay, because thermal radiation emitted by a body actually depends on the temperature, and it actually depends on the power of 4 of the temperature of that body. This one we will look into. We will see in details when you enter the topic of radiation. But now I tell you first. Okay, but the basic information you need to know here is any body, as long as the temperature of that body is above 0 Kelvin, then that body emits thermal radiation. An amount of thermal radiation emitted by certain body is directly proportional to the power of 4 of that of the temperature of that body. Okay, so net heat transfer is from the body with higher surface temperature to the body with the lower surface temperature. So meaning what? Let's say I have two objects, A and B. A is at T1, B is at T2. Okay, let's say T1 is higher than T2. Okay, so what we can say, actually both bodies, both A and B emits thermal radiation. Both of them emits thermal radiation. Why? Because T1 and T2 higher than 0 Kelvin. Okay, according to this, so both bodies emit thermal radiation. Okay, and A and B actually emits thermal radiation to one another. Okay, and the thermal radiation emitted by A falls on B, and vice versa. Falls on. Okay, thermal radiation emitted by body A falls on body B, and vice versa. Okay, but there is a net heat transfer from A to B. Why? Because temperature A is higher than temperature B. So that's why, although both bodies A and B emit thermal radiation, since TA is higher than TB, so there is a net heat transfer from A to B. Okay, because TA is higher than TB. So there is a net heat transfer from A to B. Okay, this is how radiation takes place. Okay, I hope this is clear. Okay, so this one I have explained already in the video lecture. It's not comprehensive enough. So now let me give you a little bit more explanation. How conduction takes place, right? So in solid, okay, just now I mentioned already, conduction takes place in solid, liquid, and gases. Okay, so in solid, thermal radiation happens through, it depends on types of solid. If it is a metallic solid, if it is a metallic material, so if metal, we learn in chemistry, metals contains free electrons, meaning electrons in the metal can move freely. Okay, that enables metal to become electric conductor, right? So because of the free electrons, so in metals, thermal radiation not radiation, thermal conduction, okay, happen through free electron diffusion. Okay, and in non-metal doesn't contain free electrons. So conduction happen through what? Through particle or molecular collision or lattice vibration. Okay, how does that happen? Okay, you see, let's see, in solid, heat conduction is due to two effects. Okay, number one, just now I mentioned already, in metals contains free electrons is through electron diffusion. Remember the keywords. In metals is due to electron diffusion. Okay, energy transported via the free flow of electrons in the solid. Okay, this is how heat is conducted in solid, in metals. Okay, so yep. So at this point, so electron at this point, since the temperature is higher, so electrons contains higher energy, right? When it moves freely, so it will move to this part, right? And actually, this part, electron also move to this part, but there is because since electron in this part contains higher energy, so there is a net, right? There is a net transfer of energy from this part to this part. Okay, so that's why it is called energy. Thermal energy is transported via free flow of electron, or people call that electron diffusion. Okay, you also learn this in when you enter the next topic, not next topic, part number 2, mass transfer. Okay, you will learn this term called diffusion. Okay, in non-metallic solid, heat transfer happen through lattice vibrational waves. Remember this term, lattice vibrational waves. Okay, lattice vibrational waves is induced by what? By the vibrational motion of the molecules positioned at a relatively fixed position in a periodic manner called lattice. Have you taken material science, material engineering? Have you taken this subject?
No, Doctor.
Not yet?
No.
No, Doctor.
Have you learned about crystal, what do you call that?
Crystal lattice?
Yeah, crystal lattice.
Touch a bit. I think in first year, first sem, the ITE something, but we don't touch more.
Okay, it's okay. You don't need much. As long as you know what is crystal lattice, right? You know what is BCC, right? Basic.
I think you learn it in biomaterial part in static first year.
Yeah, yes, Doctor.
Yeah, right. There's two types of lattice.
You learn crystal structure, right? So you know what is this, right? So sodium chloride, what is the structure of sodium chloride? The ion, they are held by one another because they have different the positive, negative, right? So this ion, they cannot move because they are attracted. They are fixed at the position, but they cannot move, right? Although they cannot move, but they are able to vibrate, right? This is what we call vibration. Okay, so in this kind of solid, okay, contains ions or contains molecules. Ions, for example, sodium chloride, right? Molecules, for example, plastics, right? Plastics, for example, polyethylene, polypropylene, right? All these consist of molecules, but sodium chloride consists of ions, right? So all this material, they don't have free electrons. They are fixed. The atoms, they are fixed at that position. They are not able to move. They cannot move freely like metals, like the free electron in the metals, but they are able to vibrate. Okay, they can vibrate. Okay, so in those solid, so heat transfer occur through lattice vibrational waves. This what does it mean? Okay, all these molecules, all these ions, they are unable to move freely, but they are able to vibrate. So in, let's say, okay, this solid, okay, this part temperature is higher, right? It is being burned, let's say. Okay, temperature is higher. So this part, let's say this is a wood, or this is a plastic. Okay, let's assume the plastic doesn't melt. Okay, it doesn't melt. So what will happen? How the heat is being transferred from this part to this part is through lattice vibrational wave. Okay, this part, the lattice will vibrate because the energy, thermal energy, is transferred from the flame to the molecules at this part, right? So the molecule receive the thermal energy, then vibrate greatly, right? Then the vibration causes the energy to be transferred. It causes a wave. Okay, that's why it called lattice vibrational wave. Okay, then the energy is transferred through this wave to the colder part. Okay, so that's the meaning, okay, of lattice vibrational wave. So this is what happened, how conduction takes place in solid. In gases and in liquid, it's very simple. In gas and solid, heat conduction is due to what? It's due to collisions and diffusion of the molecules during their random motion. So we know, right? You learn in physics, you learn in chemistry. So in liquid and in gas, the molecules are able to move freely, right? Able to move freely. So, that's how conduction takes place in gas and in liquids. So when the molecules with let's say this part of gas or this part of liquid, temperature is higher, right? So the molecule at this part contains higher energy. So that's why they move faster, right? They move faster. Then they move faster. Then when they move, they collide with one another, right? So during the collision, what will happen is energy transfer, right? Energy transfer. When the collision happens, then energy is transferred from one molecule to another molecule. Okay, so this is how it happened. So also then it moved to the colder part. Then collision takes place. Then that's why you see the energy is transferred from the heated part to the colder part. So this is how conduction takes place in gas and in liquids. Okay, and let's see mechanism of convection. Maybe this is something new to you. Okay, I try to explain. Okay, how convection happen? So, try to recall what is convection. Convection takes place. Convection is the heat transfer between a solid surface and a moving fluid. This is the basic definition of convection, remember. So let's see how convection takes place. Heat is first, let's refer to this, a hot block, meaning this is a solid, okay, and the surface of the solid is hot, okay. Then this is air. Air is moving, Air is moving, okay, adjacent to this hot block surface. Okay, and what will happen is heat is first transferred from the hot block surface to the air layer adjacent to the block by conduction. You see, this part you learn in fluid mechanics, you still remember fluid mechanics, in pipe. Okay, let's say this flow, this inside pipe. So you learn, right? This is the velocity, right? The middle part, the velocity is the highest, maximum. And at this part, the fluid adjacent at the pipe surface, the fluid is not moving, right? You still remember? Try to recall what you have learned in fluid mechanics, right? So at this part, fluid stick to the surface of the pipe is not moving. Velocity is 0, right? Whereby the fluid at the center, velocity is maximum. Okay, so same goes to this. Fluid at the surface, okay, fluid adjacent, there is a very thin layer of air adjacent to the hot block, which is not moving. Because it's not moving, that's why heat can be transferred through conduction. Why? Because conduction is what? The air is not moving. Okay, so I want you to understand why I say heat is first transferred to the hot block surface to the air layer by conduction, because this thin layer of air is not moving. Okay, so first heat is transferred to the thin layer of air adjacent to the surface through conduction. Okay, after that, the heat is carried away from the surface by convection. And we know that there are two types of convection: forced convection or natural convection, right? This one I will explain later. Okay. So how heat is carried away by convection? Okay, it's a combined effect of conduction within the air that is due to random motion of air molecule and bulk motion of the air that remove the heated air near the surface and replaced by the cooler air. Okay, try to recall. Just now I said convection is actually a combination of conduction in the presence of fluid motion, meaning fluid is moving, okay, and when the fluid is moving, then how conduction happen in the fluid? Just now I mentioned already. Conduction takes place in gas and in liquid when there is collision. Right? There is collision between the molecules. The air molecules, they always moving, right? Okay, it's always moving. Okay, and okay, let me explain. Even the air is not flowing, the air molecules is still moving, right? Do you get what I'm trying to say? Even the air is not moving, but the air molecule is still moving. It's called Brownian motion. Do you still remember what you have learned in physics? Even the air is still, there is no wind, but the air molecule is still moving around, right? Brownian motion, you still remember? Okay, but so then conduction happened because of this kind of motion, right? Collision. Then it happened conduction. But when on top of this, okay, then if a force is given to the air, for example, I switch on a fan, okay, then extra energy is given. Then now the air is flowing, okay, on top of the Brownian motion, right? The molecule is moving. Then now you add another force, right? Causing the air to move. Okay, meaning you feel the wind lah, right? You feel the wind. Guys, this is what we call convection. So that's why we say convection is actually a combination of conduction plus air movement. Okay, motion of air. Okay, so just now I mentioned there are two types of convection. One is forced convection, another type is natural convection, right? So how to differentiate the two? Okay, so you see this picture. It is forced convection when the fluid motion is caused by an external force. For example, a fan. Let's see this picture. Okay, if you switch on a fan, then you are adding an external force. You are forcing the air to move. This is called forced convection. But if there is no external force, okay, but the air is moving because there is a buoyancy force caused by the density difference. Last time I explained already, right? Because the hot egg surface is hot, so it heated the air adjacent to it. So the air heated, then it becomes lighter, right? Temperature increase, then density decrease. So density decrease, it will move upward, right? Then hot air move upward. Then it leave a space here, right? Then colder air move downward to fill the gap. Then it forms a motion, a flow. This is what we call natural convection because there is no external force like fan, but the motion, the air motion is solely due to density difference, due to buoyancy force induced by the density difference. This is what we call natural or free convection. Okay, and that is an important remark here. Heat transfer between the block and the surrounding air is by conduction only if the temperature difference between the air and the block is not large enough to overcome the resistance of air to movement and therefore to initiate natural convection currents. What does it mean? It means if, let's say, the hot egg surface is not hot enough, okay, not hot enough, okay, so it is not able to form the air motion. It's not able to form the air motion. In such a case, then heat transfer will happen through conduction. It will not happen through natural convection. Okay? Okay, I want to give you a little bit more. Okay, then because just now I explained to you already, if the temperature is not hot enough, then it will not, what will happen is the conduction, not the free convection. Then you might have this question, you will ask, then how should I know in what kind of situation is conduction? What kind of situation is free convection? Right? Let me tell you a little bit more information. Okay, this is what you are going to learn. This formula you are going to see in the next topic, free convection. But I give you a little bit. I give you an overview first. Don't get panic. Just you don't need to worry about this formula. I just want to tell you this is what you are going to learn in the next topic in free convection. Okay, so let me explain very briefly. So actually, for a free natural convection to happen, okay, actually there are two forces. They are going against one another. Okay, because when a buoyancy force is formed, okay, because of the density difference, it needs to overcome. For this fluid to move, it needs to overcome friction. Okay, you learn in physics, right? Friction, right? For an object, okay, to move, then you need to overcome the friction force, right? So now the buoyancy force must be big enough to overcome the friction force. Then baru you will see the circulation happen. Okay, when this happen, then you will see this air movement take place. If the buoyancy force is not big enough, okay, is not bigger than the friction force, then there will not be natural convection. Then what will happen in such a case? Heat will be transferred through conduction instead of free convection. And how to know? Okay, there is formula for you to calculate. Okay, this is what you're going to learn in convection lah. So you don't need to worry about all these things. Okay, this is actually when you enter topic number 2, you are going to see, you learn in fluid mechanics, right? Reynolds number. You're going to see more numbers after this. This Grashof number, this Prandtl number, and here one more, Rayleigh number. Okay, but don't be afraid because of long formula. Actually, when you understand, it's quite simple. Okay, it's just the formula is long. Okay, if you understand, it's actually very simple. Okay, but the principle is, I want you to understand this. Okay, how to know if it is conduction or it is convection? The principle is, if the buoyancy force is greater than the friction force, then free convection will take place. Then if the buoyancy force is smaller, is not able to overcome the friction force, then there is no air movement. When there is no air movement, then no convection. Then what will happen is heat will be conducted, heat will be transferred through conduction. As simple as that. Okay. How do you know when this bigger? There is formula for you to calculate. Right now, you don't need to worry about this. Okay. You only need to know the theory, understand. Okay. What else? Here you see lah. You see. Okay. There are 2 forces determine if natural convection can take place: buoyancy force and viscous force. A viscous force is the friction force lah. Okay. If buoyancy force is able to overcome the viscous force, a circulation flow will be formed. Okay, it means natural convection takes place. As simple as that. Okay, so that's why here it say, if you go back to the previous slide, it say if the temperature difference is not big enough, right? If the temperature difference is not big enough, meaning temperature difference, meaning because if the surface is hot enough to heat up the air, then the air become the density becomes very light, right? Very low. Then it will form a very big buoyancy force to overcome the viscous force. Then it will form the motion. Okay, this is what does it mean by that? Okay, so next, I just want to give you a little bit more, okay, information. How do you know when convection happen is due to free convection or forced convection? Actually, you can compare between Grashof number and Reynolds number. This also you will learn in the next topic lah, convection. Okay, so if it is a mix, meaning free convection and forced convection happen at the same time, you want to know which one is dominant. Actually, you can compare the Reynolds number and the Grashof number. Okay, then if the Reynolds number is bigger, much bigger, then it means forced convection is dominant. But if the Grashof number is bigger, as compared to Reynolds number, then it means free convection is dominant. As simple as that. Okay, I guess I am done with the theoretical part before I enter into the equation derivation. Any question?
Doctor, actually got one question.
Okay.
So I remember Doctor before, like from explaining the radiation part, Doctor say both surface, even the cool surface will emit the radiation wave, right?
Yes.
And then each wave fall on each surface, and then there is a net heat transfer from the hot surface to the cold surface. Yeah,
Yes.
something like that.
Yes.
So I'm actually wondering whether conduction and convection will need to explain as detailed as radiation like this.
No
Like
need.
for example, the candle flame and the wooden stick question, right? So if I explain like there is a heat energy transfer from the flame and also the heat transfer from the hand to the handle to the wooden stick, but just that the temperature of the flame is higher than the hand, and then there's a net heat transfer from the flame to the wooden stick. Do I need to go this detail for conduction and convection?
No need. No need.
Oh, okay.
Yeah.
So only for radiation.
I have gone through, I think, your group's explanation. Right?
Oh,
I think it's too detailed. You don't need to go into that detail. Yeah. But I cannot say it's wrong.
okay.
Just that you don't need to go to that detail. You only need to explain you must mention the keywords, right? Vibration, right? Collision, how the energy is transferred. You only need to explain that. I don't want to see heat is transferred from here to here because the temperature here is higher than this point. I don't want to see that. That is high school level. You are now undergraduate. And you must be able to explain, right? All those important terms, for example, collision. Then you should be able to know, right? If, for example, if it's a metal, then it's a free electron, right? Or if it is non-metal, then you should not use free electron, right? You should say lattice, right? Lattice vibration. You should be able to know the differences between different types of solids. Yeah, that is what we want to see. You understand the basic concept and you are able to deliver, you are able to explain the phenomenon clearly. But you don't need to go into that detail. Did I answer your question?
Yes, thank you, Doctor.
Okay. Any other question? Any other question? Okay, if no question, let's take 5. Okay, let's have a quick break. Now it's 9:50. Let's come back at 9:55. Okay, you can go to washroom,